We can have the selection of the organic polymers and inorganic polymers, and their impact over the nature, and all these will be very, very important parameters while selection of these organic and inorganic polymers. Okay, and thermoplastic and thermosetting polymers, you have to look into whether this mold once you have generated, if it is only for the big purpose, we can use only the thermoplastics because it can be remelted once again, and we can able to even do or get into different shapes later on by heating up. And many of these thermoplastics are those, you can see that some of the industries have taken the shape in the industries. One of the video I'll be sharing you later. The old slippers and all, they'll be taking and they'll be melting once again, they'll be preparing once. So those are the thermoplastics. Many times it can be eaten up and we can get into a required shape. They're not losing their physical and chemical properties. And the thermosetting polymers are the once they shut down, they cannot be used once again. They'll be just no use at the end once it is molded. Okay, based on what type of and when and what situation we're going to use them, based on the cost involvement also, we can have the selection of the thermoplastic and thermosetting polymers. And plastics and elastomers and fibers and liquids and resins. Okay, plastics also. Elastomers are those, they'll be having a long chain, and even you can draw them into very thin wires, and the elastomers will be having very good the super elastic properties, and these elastomers will be having very good elastic properties, so that even it is stretched with a thin wire also it will not break. Okay, some of the fibers and the liquids, these are the main important classification. And I wanted you to look into the molecular weight. What is this molecular weight of this? Okay, and number average molecular weight and the weight average molecular weight. These are some of the terms will be coming across. Okay, while you are going to study about these polymers, but we are not, in fact, we are not going to do any kind of problems. We are not going to do any kind of problems on them. And let me have a small look about this disparity and molecular weight and distribution in the polymers. And you can look into the simple chemical composition, monodispersed systems and polydispersed systems. Monodispersed and polydispersed. Monodispersed, the molecular sizes will not be changed. Okay, the molecular size will not be, size shape will not be changed. And in this polydispersed system, the molecules are having the different sizes. The molecules will be having different sizes. So this is called monodispersed and the polydispersed. The title itself will be showing you the polydispersed. Polydispersed in the sense that the dispersion of these molecules will be in the container, which will be having the different sizes. Monodispersed, that means you look into any reason, there the size, shape and size will be remain same. That is monodispersed system. And based on this monodispersed system and polydispersed system, and casting them into a single unit, which method we are going to employ, that will be mattering here by looking into this monodispersed and the polydispersed systems. Okay, and now how these fibers will be spent. So impact, whether it is a naturally available or synthetically, and whether it is the elastomer or polymer or thermosetting plastic or this one, the different type of polymers, whatever you say, those will be available in the powder form, and this powder form will be converted to a thin wire or some kind of laminated sheets. Okay, so for this, what are the different techniques will be employing for the fabrication, that is the fiber spinning. And there are three principles of spinning: melt spinning, dry spinning, and wet spinning. You can see look into the before you get into the content, look into the definition or word, the melt spinning. Melt spinning is before this the fibers, polymers, which are available in the powder form. Okay, and those will be put into a panel, and before you get into or take it to the required shape, it will be melted. Dry spinning in the sense we are not going to meet them up, just we are going to heat them up. Dry spinning. Wet spinning is the wet method, wetting method. Okay, that will be made to pass through the series of rollers. So it will be forming it will be resuming the shape of the die or form, whether it may be the rectangular cross section or square cross section or a circular cross section, or it may be a thin foil of sheet or different shaped sheets. Okay, so series of rollers are used to make a pass through, and a sheet also can be developed in the wet spinning. So please try to remember the three principles of spinning: melt spinning, dry spinning, and wet spinning. Okay. Now let me look into this melt spinning, how this melt spinning is. So please try to go through this figure which is presented here. There is a hopper. In this hopper, the granules of these polymers will be put into this. This will be available in the powder form. And immediately after this, it is made to flow through this hopper outlet. And here there will be a container. In this container, these polymers will be melted up. So that melt spinning. So before we spin them to the required shape, it will be melted. Very simple word. So in this particular zone, it will be heated up. Then that hot, the liquefied polymer is made to flow through this pump, and it is spin rate. Okay, it will be spin rated. And after this will be made, or it will be converted into solid form. Here the air will be circulated in order to cool down it, and again once it is cooled down, what happens? Totally it will become solidified. And if you want to bend them up, what happens? There will be a problem. If you want to bend them up, it will break. So in order to avoid this problem, what we are going to do is we are going to pass this steam over this. Once it is moisturized, what happens? It can be bended. We can bend it to the required shape. So it will be made to flow through this yarn rolls, driving rolls, and the feed roll, and there will be bobbin. Bobbin means a roller on this particular spin wire will be made to wound up on this. It is a melt spinning. So melt spinning, it consists of a hopper that is called a feed hopper. There will be outlet, and here the polymer granules. The polymer granules may be a polygranular or monogranular. That means the different shape also can be used here. You can see that. Okay, and here as soon as it enters into this heat zone, what happens? The polymer will melt. That will be heater will be provided, and this hot molten, that means the liquefied polymer will be made to flow through this pump, and then it will be spinned. Spin rate. The spin rate means it will be spinned. If you want, you can make it to a thin wire and fibers just like that. And this particular region is a molten region. That means still it is molten. And so that to make it solidified, air is circulated over this. Once the cold air is circulated, it will be solidified. And before it is let into this bobbin is a roller. On this roller, it will be wounded. Okay, and it is made to pass through this steam. It will be steam conditioned. That means whatever the wire we're going to wound them together, what happens? These wires will be separated. While you are going to decoil it, what happens? Once at a time, there may be a possibility that it may be adhered to the neighboring coil or neighboring thread also. Should not happen. So that it has to be independent while taking, so that it will be treated with the steam in order to make it moisture, so that in required shape it can be made before it passes through this. And the bobbin, before that, you can say that you can see a feed roller. The feed roller will be feeding at the required rate, so that the winding and the flow of the material over this feed roller should be same, so that it should not be tightened so, and it should not loosen too. Okay, yarn driving roller is one that will be directing.